Okay, good afternoon, class. So at this point, we are looking at exponents and surds. We are on the second lesson, basically. So we're looking at the examples for exercise 1.3, which is on page 6. We're looking at operations involving powers, multiplying and dividing. Later on in the video, we're going to look at addition and subtraction. However, this example is example 1 on page 5. Okay. So at this point, we have dealt with this topic before. Okay, the sum is just getting bigger compared to the grade 11 syllabus, grade 10 syllabus. Okay. So the first step is we need to break this up into products of its prime factors. The basis we're going to break up into products of its prime factors. And 9 can be written as what? 3 squared. So that's raised to the exponent, a plus 1. The 3 with the remaining 3 as it is already in a prime base. Over 27 can be written as 3 cubed raised to the power a plus 1 times 9, which is 3 squared raised to the exponent a minus 2. Okay. So what we do if something is raised to a higher exponent, we multiply the exponents. Not so. That's going to give us 3 to the 2a plus 2 times 3 to the 3a minus 4 over 3 to the 3a plus 1 times 3 to the 2a minus 2. Plus 3. Yes, plus 3, and yeah, it's supposed to be negative 4. Not so? That you're saying is supposed to be 3. Absolutely correct. There's a common made error. Okay? Where they don't multiply that exponent with that term. Also at this point, if you don't, now we got 3 squared, you can either use decomposition method, or you can use the ladder method, or we can use our calculators. Okay? Just get it in the right format. Yeah? So if you say 27 equals, you put the shift, then this button here. Okay? The shift to activate any yellow key, which is 3 cubed, which is 1008 equals shift. Factorize 1008 can be written as 2 to the exponent 4 times 3 squared times 7. Okay? So that's another way of writing a number in products of its prime factors. Of course, it has to be a natural number. Okay? So when we're multiplying and bases are the same, what do you do to the exponents? You add them. So that exponents will be added. So it's 3 to the 2a plus 2 plus 3a minus 4. And when we're dividing and bases are the same, subtract the exponents. So it's negative 3a minus 3 minus 2a plus. So it will be 3. What is 2a plus 3a? 5a. Minus 3a is 2a, minus 2a is 0. So that cancels. Okay? So 2 minus 4 is negative 2 minus 3, negative 5. Plus 4, negative 1. That is simply 1 over. So for those of you like the writing notes, the first point would be, we'd write it in products of its prime factors. Okay? Secondly, we multiply the exponents. Thirdly, when we're multiplying and bases are the same, we add the exponents. We divide, we subtract the exponents. That's the step that I've just done there. And from here it is just to simplify. Okay. Any questions? Any confusion at this point? No? I'm moving too fast. No. Okay. Now we're looking at the example 2, and example 2 is on page 6. Okay. Example 2 is on page 6. So what do we have to do first? Put Break the bases up, yes, into products of these prime factors. So 6 can be written as 3 times 2 or 2 times 3 is raised to the exponent a plus 1. Again, if you don't know how to do that, you just press 6 equals shift factorize. It's 2 times 3. Okay. 9 can be written as 3 squared raised to the exponent a minus 1. This is all over 2 to the a plus 1. And 27 can be written as 3 to the exponent 3 raised to the So what do we do now? Multiply the exponents. If there's no exponent, there's a 1 and a 1. Not so. So that will be 3 to the a plus 1 times 2 to the a plus 1 times 3 to the 2a minus 2 over 2 to the a plus 1 times 3 to the 3. So what do we do now? When we're multiplying it, bases are the same. Add the exponents. So only the exponents with a 3 will be brought together. So it's 3 to the a plus 1. We're going to add this here. So it's going to be plus 2a minus 2. And then minus 3a times. Multiply by 2. A plus 1, yes. Minus a. Minus 1. That will be 3. A plus 2a minus 3a cancel. So a 1 minus 2 is negative 1 times 2. A minus a cancel, 1 minus 1 cancel. So I just leave it like that, or must I write the 0? 0. Right? So if I left it like that, that is it would have been a 1 there. Anything to the power of 0 is? 1. So 3 to the negative 1 is 1. Those of you who don't know how about that, so 3 to the negative 1 is 1 over 3. Or we're using that rule that says x to the minus 1 is 1 over x. So 3 to the minus 1, of course, is 1 over 2. Okay. This was dealt in the previous exercises. Okay. Yeah, that rule we have been applying since grade 9. Okay. Any confusion? Alright. Now we're adding and subtracting powers. When we add and subtracting powers with unknown exponents, use the following method. First, we're going to split the power with the unknown exponent. Okay, so we got a to the m plus n, can be written as a to the m times a to the n. Factorize by taking out the common factor. Okay. So we'll make this note soon. We just do the examples because I don't want the video to be too long. Okay. Example 1 on page. Which page is this on? Page 6. Example 1 on page 6. Okay, so again the question is to simplify. We've got 3 to the n plus 3 to the n plus 1 over 7 times 3 to the n. So what was the first rule they said? You must break up the bases, not so. So looking at 3 to the n plus 1, that can be written as 3 to the n plus 3 to the n times 3 to the 1 over 7 times 3 to the n. Why didn't I break up 3 to the n? Okay, you can't simplify that. Not so. You can't break it up because there's only one term in the exponent. Why are we not going to break that up? Because 7 times 3 to the n is already broken. You guys understand? So what do I do now? We look for a common factor. And what is common in the numerator? 3 to the exponent n. What are we left with? 3. You all agree with that? Who agrees with that? Tap your hand. Why you disagree? You not? Your hand is up. You agree. Now she does this. Her hand is not up. Not up. Right. Now why is your hand not up? You don't know why your hand is not up. Would you like to put up your hand?
I don't know, sir.
You don't know. Who disagree with that? 1 plus, yes. Well done, Leanne. Alright. Remember people, if we got 3 plus 3 to the x, what is common here? 3. What are we left with? 1 plus x. Not so. So whenever we take out the whole term as a common factor, we must put a 1 there. You guys understand it? Am I moving too fast? No. Okay. And this is all over what? 7 times 3 to the n. Now what? What do you do now? You can cancel. What can cancel? 3 to the n over 3 to the n. So what's 1 plus 3? 4. Well done, people. I feel like we're getting somewhere. No? There's 4 over. You guys understand? Let's look at the next example quickly. I'll give you a chance now to write down. And then we'll do, after the video, we'll do a couple of sums together, okay? For those of you who want to watch the full video, the full lesson, it will be in the description box below, okay? Are we still on page 6? Is example 2 on page 6? On page 7. And exercise 1.3 is on page? So why didn't you tell me? Are you scared of me? Not anymore. Okay. Okay, it's page 7, huh? Okay. So what do we do first? First things first. Go to our friend, yes? No? We break up our friend. No? Don't break up friends, no? We're going to break up this basis here. Not so. So 5 to the n plus 1 can be broken up. 5 to the n minus 1 and 5 to the n minus 2. Okay. So 5 to the exponent n plus 1 can be written as 5 to the n times 5 to the 1 minus 5 to the n times 5 to the negative over 2 times 5 to the n times 5 to the negative 2. We'll come back and we're going to write those notes down. What note goes there? First break up the basis. Okay. What is the next step? What is the next step? Take out the common factor. And what is common in the numerator? 5 to the exponent n. Not so? 5 to the n. What are we left with? 5 to the 1 minus 5 to the negative 1. And this is all over 2 times 5 to the n times 5 to the negative 2. Okay. Now what? Cancel. So what do we do from here? Simplify. Here we're going to simplify. So we got 5 minus 5 to the 1 can be written as 1 over 5 over 2 times 5 to the minus 2. 5 to the minus 2 is 1 over 25. So it will be 2 over 25. The LCM of course is 5 here, so it's 25 minus 1 is 24 over 5 divided by 2 over 25, which is the same as multiplied by 25 over 2. Okay. So 2 goes into 2 ones, 2 going to do 24 12 times. 5 going to 5 ones, 5 going to 25 5 times. 5 times 12 is 60. And there we go. Okay. Otherwise, what I could have done was I could have said, okay, this here, I'm going to put that in a bracket, in a fraction, and in your calculator. Then you put that whole fraction in the calculator. So it's 5 to the exponent 1 minus 5 to the negative 1. This is all over 2 times 5 to the negative 2. This is also which confirms my answer of 60 squared. Okay, you guys understand?
Yes, sir.
Any confusion here? Any questions? Alright. That basically brings us to the end of this video. Okay. With this you should be able to do exercise 1.3 on page